welcome everyone to another Space and Information Domain webinar hosted by Beca and SpaceBase. Today we'll hear about New Zealand's space ground systems. If you'll advance, next slide, please. So again, this, as you've heard before, if you've attended these in the past, this is intended to be a forum with global reach for the community of New Zealand space and information domain stakeholders to share information, connect with one another, and support the advancement of New Zealand and Trans-Tasman space initiatives. Next. So today, in the fifth in our series of webinars, we'll focus on space technologies a little more down to earth. Ground Systems Service Providers, Zero Earth Observation Institute, and Space Operations New Zealand. To our audience, while our speakers are presenting, please feel free to submit your questions via the Q&A panel at the bottom of your Zoom screens. We'll hold questions until the end, until both speakers have finished, but really do appreciate that this is as much a dialogue as we can have. So encourage you to ask questions and share commentary with our speakers. Next slide. Great. So for introductions, Duncan Steele is a space scientist, astronomer, and author with over 30 years experience in space programs around the world. His research has focused largely on asteroids, comets, and meteors, and has also included planning for missions to Mars and search for life elsewhere. Today, Duncan is a principal research scientist at Zero Observation Institute, creating powerful new ways to utilize Earth observation and remote sensing technologies to support evidence-based decision-making within New Zealand, industries, businesses, and government. Please welcome Duncan Steele.
Thank you, Jessica, for that very kind introduction. As you said, I work for the Zero Earth Observation Institute. I'll be talking today about our platform called Starboard. It's all about space-enabled maritime domain awareness. We like to say this is a world leader. That's a phrase which is kind of bandied around, but it really does appear to be that way, in that we've got a lot of interest in this platform from all around the world now. So it's not just New Zealand. We're certainly dealing very closely with particularly Australian government departments and various different agencies and companies there, but indeed we've got global reach. So this is, if you like, a New Zealand success story. The Zero Earth Observation Institute is a regional research institute set up with New Zealand government funding from MB about a bit over 4 years ago now. And we realized that a country like New Zealand, with a huge exclusive economic zone and also in its Pacific context, requires that we have ways of patrolling the Pacific for the good of both New Zealand, the Pacific Island nations, Australia, and indeed nations elsewhere in terms of things like illegal fishing, drug smuggling, and that sort of thing. So I'll be talking about Starboard today. So we were delighted 2 months ago now, on the 21st of March this year, to hear that we had not only won 2 awards in the New Zealand Biosecurity Awards, but also we actually got the Supreme Award. And the Ministry for Primary Industries put out a press release which said this: that biosecurity efforts have been expanded into space, with Zero Earth Observation Institute, leading edge software which is helping protect Aotearoa from pests via international shipping. The pests involved there are various insect pests, which we can identify vessels which are particularly at risk in terms of bringing such things into New Zealand. But also we were closely involved in terms of monitoring which vessels might be bringing in COVID-19 when we were trying to keep the borders tight around New Zealand. Clearly, flights in and out were severely restricted, but also vessels needed to come and go. And it was a matter of, well, where's this vessel been? How long has it been at sea? And those sorts of questions, in order to get some sort of an assessment of whether there was a risk of COVID-19 being on board. That would also include knowledge such as how big is the crew, how big is the ship, and therefore how big is the crew, and so on. So this is very much a team effort. The Zero Earth Observation Institute, a very mixed group of people in terms of their backgrounds and so on. As you've heard, I'm a space scientist, physicist, mathematician, you might say. But we've got a very large complement of software engineers who do absolutely brilliant things in terms of manipulating, handling, analyzing the data which we have coming in from a variety of satellite systems. And I'll be talking about those today. So what is Starboard? Well, it's a platform. It's a web-enabled platform. You can look at it on a web browser on your laptop or desktop machine, but also it has to be usable by people who are very much in the front line, people like customs, quarantine, and so on, who are actually checking on vessels as they come into New Zealand waters. So it's also can be put onto a phone. It's very portable. The main data source which you use is the Global Automatic Identification System, AIS. That's a abbreviation I'm going to be using quite often as I talk this afternoon. But it's not just the induction of the data. Lots of people, lots of different companies around the world induct the data and put them up on maps to show where vessels are. The clever thing, if you like, which we're doing, the complicated thing we're doing, is an automated analysis of those vessel tracks, and in order to identify such things as fishing. So this particular example shown just here shows fishing behavior. Where it's pink, that's an automatic identification of the sort of behavior which we might have expect a vessel to be executing if it were fishing. You can also see a symbol here with two arrows going backwards and forwards. That's an automatic identification of when that vessel has actually had an encounter with another vessel. So this particular ship could be a fishing vessel, but it's met with a bunker ship or or another vessel which is an oiler which is bringing it more fuel, or some other vessel. So we do all that in an automated fashion. Have two vessels being within a certain distance of each other for a certain length of time. Now, this is a big, complicated problem. This is just 1 week of AIS vessel tracks across the Pacific and the Indian Ocean. You can see it is pretty complicated. It's kind of interesting to look at. You can see that a lot of the vessels doing very long runs, say from the Panama Canal across to Tokyo. They're following, by and large, great arcs. That is the same sort of path which you would expect a jetliner to follow, because it's the shortest distance, but of course they also take into account winds and currents and so on. What is interesting when you look at both the Pacific and the Southern Indian Ocean is there's a lot of vessels going backwards and forwards, and those are fishing vessels. They're executing different types of tracks. So if we take a look at ship movements over just 10 days here, you can see that there's a lot of fishing activity in the middle of the Pacific. And you can also see there's lots and lots of other dots which seem to be not associated with any track. Those are things which we call ghost ships. There aren't actually vessels there. It's single AIS positions which have come up because, hey, maybe it's a vessel which is deliberately spoofing its location, but more often it's a matter of an incomplete signal having been derived, and so the latitude and longitude is just plotted incorrectly. And we have ways of excluding those. Clearly, if they're just single announcements of some absurd position, for example, this appears to show their vessels within the landmass of Australia, we know that's not true. And so we have an automated way of weeding all of those out. So ghost ships get to disappear. That's the first step. Overall, though, we've got to ask ourselves, how do we make sense of the whole thing? How do we make sense of this huge, complicated picture? Well, the first thing we can do is, as shown in this red box at the top, I'm showing all the vessels which are on this map, that is within my screen, and that is involving no weeding out in terms of what is it I'm interested in looking at. So let's take a look at something different. Let's imagine that we're only interested in vessels within the New Zealand exclusive economic zone, which goes out to 200 nautical miles, 370 kilometers from any point on the land. And let's say we're only interested in selecting those vessels which have entered that area from overseas. All of a sudden, things get much simpler. There's quite a few vessels. It lists there's 79 on the screen which have entered that vessel over the 10 days for which I've selected here. And so that actually can tell people like customs, immigration, quarantine, and so on, hey, there's a vessel which has entered the exclusive economic zone. We can predict which port it's going to, based purely upon its track, but of course they're supposed to report which ports they're heading to ahead of time. But all those sorts of things can be done, and we can, as I say, kind of weed out from the huge number of signals just those which we're interested in. The other thing which can be done is that we can examine the activity of these vessels. So here in this blue box, we've selected all activity, but I could have clicked COVID-19 risk. I could have clicked hitchhiker pest risk. If I click hitchhiker pest risk, it actually looks for insect pests possibly on board from looking at the past history of that vessel over the last 18 months. So has it within a certain period of time been in one of the ports which are regarded as being risky because of their geographical location? So brown marmorated stink bug and another moth which has been renamed. It used to be called Asian gypsy moth. It's now called spongy moth. We can identify which vessels are possible carriers of that. So it's a selector for the quarantine people to be able to know which vessels are the riskiest ones. And it's achieving a huge amount of use in that regard. The traditional way in which AIS data has been handled is we say is kind of flawed in that it's really a manual analysis. And what we're doing is we are doing an automated analysis. So for example, we can highlight in a vessel track, and this is a fictitious track we selected. We can highlight anomalous movement. Why on earth was this vessel doing a loop-the-loop out in the middle of the ocean? A dashed line means that there's missing AIS data, usually because they've switched off their AIS transmitter on board. If it's going slower than usual, we highlight it in gray. We show the track in gray because we call that loitering. Here we find that another vessel, which has come from the south, fishing here, and then has met this vessel here. We look at the characteristics of the vessel, what we know about it in terms of a huge database, and we identify this particular vessel as being on the global IUU list, that is the illegal, unreported, and underreported, and so on fishing list. So it's if you like, a vessel we want to keep our eyes on, and this shows there's an encounter. Here, the bell means it's actually entered the exclusive economic zone, and here is the vessel continuing. So all of this can be done in an automated way. We can monitor fishing vessels and marine reserves. Now, here's an example of the subantarctic islands of New Zealand. Here, we're looking at vessels. They're not doing anything illegal here, but it is interesting to see what sort of tracks they've taken. Here's one called Ocean Pioneer, which has come down. Obviously, it was intending to fish out here, but then there was a storm. It zigzagged up and down here. It's headed out again. Another storm or unfavorable conditions. It's come back into a cove here, which it's allowed to do. And eventually it comes out and we see it's got fishing behavior out here. So that's the sort of thing we can do in an automated fashion. So how do we do it? What is the space component of this whole thing? So we've got worldwide identification and tracking of the vessels. So we've taken a look at the automatic identification system. Those are actually received both by terrestrial antennas out to about 30, 40 kilometers from the coast. But more important here is they're observed out on the middle of the ocean by orbiting satellite constellations. We also use satellite-based geolocation and navigational radars. All vessels tend to have a radar operating on board, either in the S or the X band, and those could be picked up from certain specialized satellites. We use synthetic aperture radar from orbit and also optical satellite imagery. The final one of those is probably the obvious way people might expect us to be looking. I'll say a little bit more about that in just a little while. The AIS signals, there's various constellations which can pick these up. Currently, we're using the constellation from Exact Earth, a Canadian company which has recently been taken over by a larger company called Spire. They've got receivers on board, actually 58 of the 75 Iridium Next satellites, plus another 10 satellites. And so we get pretty good coverage. This black path is actually a research vessel which went down to the Antarctic at the beginning of 2021. And in collaboration with those, we tested out how the coverage of AIS actually does. So I mentioned optical satellites. Really, optical satellites only cover small areas, so you need to know where you need to look. Out on the middle of the ocean, you're unlikely to pick up a vessel, but there are certain crossroads. So for example, for yachts coming down from Fiji and Tahiti, very often they'll stop at the Minerva Reefs, which are 2/3 of the way between Auckland and Fiji. If we take a look at North Minerva Reef, here's a planet satellite image, 5 or 6 kilometers across, no vessels apparent. In this vessel, there's actually at least 10 yachts at anchor. And so we can see where there are vessels anchoring there, and we can get some idea of whether those are heading down towards Papua or Auckland. Now, an operation we've just completed, we called Operation 18C. I'll say why it was called that. This was searching for dark vessels, fishing for southern bluefin tuna in the Tasman Sea. We did that in connection with a big exposition which has recently finished in Sydney, the Indo-Pacific Expo 2022. What we did was this: we're searching for dark vessels fishing in the Tasman Sea, this area here, and you can see two big blocks here. This is historical data from 2020. This is data from just a couple of weeks ago, the 8th, 9th, and 10th of May. This is a Japanese fleet, and you can see they're going east-west, east-west. They're fishing, long line fishing for tuna. Where would we look if we're looking for these vessels? Can we get a prior idea from satellite data? The answer is yes, we can. First of all, the sea surface temperature will tell us something about where the fishing vessels will be, because the sea surface temperature also tells us something about where the tuna will be. The tuna are chasing things like plankton, which are in turn eating sea surface microbes. So if we take a look at the sea surface chlorophyll A, chlorophyll alpha, that will also tell us something. It happens that this boundary, this temperature boundary where we expect the tuna to be congregating, is at about 18 degrees Celsius. Therefore, that's why we call it Operation 18C. So that operation is finished. You can see much more about it. We've got a whole lot of videos and so on, which are put up and linkable from this particular page. It's had a very large number of hits already. It really shows how we've been using satellites, getting them tasked to collect the data which we need to analyze and try to identify who's fishing where, whether they're doing it legally, whether there's any dark vessels there. So this is just the sort of coverage we can get from different types of satellites. RadarSat-2, which is a Canadian company, MDA's satellite. We have used that. We've used other SAR satellites in the past. We also collaborate with a French company called Unseen Labs. So they've got RF detection satellites, which pick up the navigational radars, X and S band from vessels. So this is, if you like, a cartoon showing the sort of thing we do and the sort of coverage which the exact Earth satellites can pick up the AIS signals from. So we put this out ahead of time because we didn't want to tell people where this operation was going to be. In the end, it was indeed Tasman Sea, and here is one typical data collection by a Unseen Labs satellite called BRO3. Shown in purple or violet here is my kind of crude model of their sensor coverage. What they've actually collected, they say, is within this white box as the satellite flew over, and the various dots which are in there are RF emitters, that is navigational radar emitters within that sensitivity box. There's one which appears to be dark, that is, it doesn't have an AIS signal associated with it. However, there are several others for which we do see associated AIS signals, and we search for those automatically. So we're looking at where the geolocations are of the navigational radars and comparing it to where the AIS signals tell us vessels are. This is another collection in the same operation. So this was on the 9th of May. That's universal time. So that's more or less the start of the 9th of May, New Zealand time. The red dots are dark vessels. They are apparently navigational radars for which there are no associated AIS transmitters. These white dots show ones which have been picked up on RF, but are also AIS transmitters. So those are match vessels. Across here, out of the field of view of the satellite on that particular occasion, was this Japanese fleet. And they're not doing anything which is bad. They're entirely entitled to fish there, but they do have to have their AIS transmitters on. RadarSat-2, just to finish off, we also had scans by RadarSat-2 across this area. Here's a typical scan, about 66 seconds data collection. It maps the ocean, 225,000 square kilometers. We have a system for an automated search of the image to pull out the vessels which are in there. Here's a typical RadarSat-2 image overlaid on the Tasman Sea, and you can see all sorts of vessels were within that region. Here's one from just the 8th of May. And again, we've got various vessels which match, their AIS signals match for where we find a image in the synthetic aperture radar image. But there's also various others, 1, 2, 3, 4, 5, 6, which are apparently vessels, but are dark. That is, they don't have their AIS transmitters on. So here across on the left is one of those images, the one in this orange box here. And looking at that by eye, we check all of these for quality assurance. We'd say we're mediumly confident that that is indeed a vessel. It looks like a vessel. It's the right sort of size. It's a strong echo, but there is always the possibility it's something else. You know, it could be just a freak set of waves meeting at one particular point and producing a lot of backscatter, but that's kind of unusual. You'll also see there's various dots here. Those are actually buoys, and there's a whole string of buoys here, these little circles. Those are actually buoys which have AIS transmitters on board. So vessels will put those out as fish aggregators and come back to them later, and they use the AIS signals themselves to find out where their buoys are. And again, we track all of those. We induct 35 million positions a day from AIS signals globally. So that's told you what we do with Starboard. It's space-enabled maritime domain awareness. If anybody's got any follow-up, any questions they'd like to ask, please do so. We're always happy to talk to you, as it says to here, talk to us. And we're always happy with prospective partners or customers to give you a trial on Starboard for a week or two so you can see what it can actually do. It is an extremely powerful system, and it really is now doing extremely well on a global basis. So thanks very much for your attention, and I'll hand back now to the good people at Beca Connect.
Thanks, Duncan. So now, just to remind attendees that submitting your questions via the Q&A function down at the bottom of your screens, we really do welcome questions for both of our speakers, and we'll give each a chance to answer after the presentation from Space Ops New Zealand. So Robin McNeill is the CEO of Space Operations New Zealand. Robin's career is built on designing and building remote and rural telecommunications networks and satellite ground systems in Antarctica at the equator and halfway in between. His reputation in the space community derives from his pioneering work in the Ararua satellite ground station starting in 2004. Robin is a fellow of Engineering New Zealand, a senior member of IEEE, a member of AIAA, and adjunct fellow at the Department of Electrical and Computer Engineering at the University of Canterbury. Please welcome Robin McNeill.
Yeah, hi. I just got the screen sharing on, and there we are. Now we should all be happy. Yeah, kia ora tēnā koutou katoa, ko Robin McNeill ingoa. I'd like to talk to you a little bit today about what we're doing at the very south of New Zealand. And just a little bit more about me. I was born between Sputnik and Gagarin. That explains the white hair. And as Jessica said, I've been involved in building satellite ground stations for quite a while now, working for ITU at one stage too. But the little bit more about Space Operations New Zealand. We're fairly unusual. We're a wholly owned subsidiary of Great South, which is the Southern Regional Development Agency, which is owned by, in turn, by all the councils in the southern region of New Zealand. So just sort of slightly different. And our areas of interest, our core bread and butter lines are hosting other people's antennas. Some of the well-known ones were just Duncan was talking about, Spire, Planet, Kongsberg Satellite. And we install those, we maintain them, and we do the RF licensing and so forth. And also we have our own antennas that we operate and that we lease out. We do other things too, and I'll talk about them shortly. And Ararua is the correct pronunciation. Awa meaning water, Rua meaning two. First discovered from space by Tintin in 1953, so it's unique there. What it looks like in reality, I haven't got any up-to-date photos of the site. This is fairly old. It's in June last year. It's been quite a lot more development there, but you can see we're hosting a number of antennas and radomes. They just keep the antennas dry and out of the wind. And we've had quite a big development here over the last 6 months, in fact. We also have an Invercargill office where we've got a team of engineers, software, hardware, and space operations. So Ararua itself is an ideal for a ground station. It's flat, which means we can see the horizon down to better than 2 degrees in all directions. We're at the end of the world, People in Auckland, New Zealand think we're at the end of the world. people in Europe think we're definitely at the end of the world. And this is great because, as I'll explain shortly, that gives us fantastically good coverage, and we've got a unique site that is geographically significant. We've got a ton of room available for putting antennas left. We've got very good internet access, any number of 100 gigabits per second, fiber coming out, and shortly we'll have even more fiber with very low latency into Australia when Hawaii Cable lay their new fiber. We've got green electricity. We know what we're doing. It's really important in this ground station business. We've got very low background interference in our radio spectrum that we use, and unique in the world just about. We've a very popular band that's called S-band. We've got plenty of room in there, and it's very easy to be able to operate these things. Just a little bit more about why we would be important here. You can see is our station, this low Earth orbit satellites are going around the world in about 1.5 hours, depends a little on how high they are. And here's one of our customer satellites. A lot of them go over the North Pole, South Pole, and then around and around. And so obviously if you have a station at the North Pole, you can interpret, download the satellites or talk to them every time. Same with the South Pole. The trouble with the South Pole, there's no fiber there and there's no stations there. Well, it's two, but they're quite difficult to get data out of three. And so you can see at Aotearoa, being as south as we are and as east as we are, we're in a very good position to be able to get multiple passes. And for the people who believe in the flat Earth, you can see here the satellite coming down, and we'll see it again, and we'll get 2 to 3 passes on a descending orbit, and then 12 hours later we'd get them on ascending orbit. So that makes us pretty significant. There's a few other subtleties on that map of the world, if you look at it, which makes us very attractive. Not everyone in the audience, I guess, is going to fully understand what I'm talking about, but we all know of satellite ground stations. A lot of people have Sky TV or something, and they've got an antenna on the roof, a set-top box, and here's the payload. We've got exactly the same thing. The satellite we communicate with, instead of being 36,000 kilometers away in geostationary orbit, much lower down, so we have to have an all-sky antenna that can move in all directions, which makes them rather more expensive than the geo antennas. And you've got to typically point them within 0.1 of a degree. Then the set-top box, that's a little bit more complicated for what we're doing, but essentially it's doing the same trick. And then the payload, a fantastic movie, those who haven't seen the dish, but our payload looks a bit like that. Instead of looking at pictures, we're very much focused on the data itself. As I said right in the beginning, our primary bread and butter line is hosting other people's antennas. We've got antennas here from global navigation right through to a whole range of antennas. You can see there. We started off doing this back in 2008 to support the European Space Agency's ATV resupply missions to the International Space Station. This thing here, the ATV, think of it as a 20-ton cargo truck taking clothes, food, air, and science experiments up to the astronauts and cosmonauts, and that fits in here. And basically the 2 different contractors providing these services, and we were working with the French Space Agency and the European Space Agency for the launch vehicle itself, not ATV, launching from Kourou, French Guiana, the International Space Agency's, European Space Agency's International Spaceport, ballistic phase. And then as they came over Australia, they did a stage 2 burn, and then very importantly, over the back of Aotearoa, they separated the launch vehicle from the payload, and that's the moment of truth where either everyone was going to hand out the cigars, which is what they did, or if it hadn't gone well, to get on the phone and talk to their insurance companies about what to do with $250 million of gone wrong space. 2008 was a pretty interesting year, I think, for New Zealand. I think it's when we went to space. Dr. Chris Hann at University of Canterbury Rocketry started his UC Rocketry group, which provided a lot of the engineers for guidance, navigation, control for Pete Beck. at Rocket Lab, hopefully you've all heard of, who launches from Mahia, and Pete also announced his ATIA 1 and really got Rocket Lab going. And at the same year, we did our first launch campaign with the European Space Agency and the French Space Agency. So we carried on doing that, wondering what to do next, and Planet Labs turned up and introduced to us by Pete Beck, saying, could we assist with the downloading of these things? These are they're Dove satellites. They're only 300 millimeters by 100 by 100 in this area. And so we built antennas down here at Aotearoa for them, and we were there just by a matter of weeks, their first stations outside of the United States. And we've had a long ongoing relationship with them ever since. And in 2018, we were really delighted to be able to support Peter Beck's Rocket Lab first successful launch. And Pete had Spire and Planet Lab on board, and I was able to happily tell Pete that he had 2 customers, we had 3. So that was, yeah, we've been delighted to be working with Rocket Lab. So what we've been doing is providing all the support structure to make these events happen. We own the land, we do the foundation design and construction and fabrication. We've got skilled contractors that we've worked with for a long time and got very good partnerships and relationships with. We erect the antennas and maintain them. You can see a radome here being put together, and here's the dish before it gets covered by the radome. And yeah, there's moving parts, so there is a bit of maintenance required. Excuse me. Our antenna leasing is growing great guns. There was a lot of demand for it. We have a S-band, X-band ground station. These are the that's a 3.7 meter dish that we commissioned last year. These are looking at the satellites that Duncan was talking about before. We also support smaller satellites or startup satellites, and some constellation work too. We've got a few more antennas we're leasing, and we've got a few more antennas in construction right at the moment. That's looking very good at the moment. Tied in with this is radio spectrum licensing. There is a whole art and a skill to that. And happily in New Zealand, we've got radio spectrum management in Wellington, part of the MB, who are very cooperative, very helpful, obviously abide by the rules, but yeah, we own something like about 200 licenses, because to have a radio transmitting license in New Zealand, you have to have someone in New Zealand, premised on the basis that someone can turn the transmitter off if you're causing harmful interference. So it's quite a lot of work in that. We're pretty good at it now. We also get involved in space operations itself, and I think we're doing a few things, but we had a lot of fun a year and a half ago with University of Auckland's APSS-1 engineering, their satellite that they launched. That was a student satellite. Unfortunately for them, I guess, a lot of the students had graduated before launch, and so we had to reverse engineer it. You can see here, these are typical, it's a CubeSat. That's a standard building block for in the small satellite world. These are I co-supervise a PhD and a master's student. We have other students that we work with at an undergraduate level as well at Canterbury. So we got that going. And an area that we're getting very much involved with now, in fact, we're working pretty hard right now to actually get ready for a launch in a couple of days, is what's called launch and early operations phase. When you first launch a satellite after separation, the first thing you want to know is it alive? Is it working? And so you've got about 36 hours at the most sometimes to know if everything's going well. Are the solar panels deployed? Is the radio working? Are the batteries charging? And we're in particularly good geographic location in the world to be doing this, and that's an area we're working on. And we'll be supporting a few launches in a couple of days, all going well, in fact, and we'll be supporting other ones too. Global Navigation Satellite System, I can't talk too deeply in this right at the moment. Hopefully we can make some announcements a bit later in the year. We work with the European Space Operations Centre for hosting one of their pedestals. So we could see the Kaikoura earthquake here. And good news for our Australian colleagues, we're moving closer to you at 42 millimetres a year. You can see tracks. We've done work with Frontier SI, which used to be one of the CRC SIs. And we'll have more work on this. We do our own research and development, antenna feed horns, antennas, circuit boards, working with a variety of partners in Australasia, it's a very good way to keep staff motivated and interested, especially when you've got bright engineers doing R&D. This board here, we hope to be selling in small sat in Utah in a couple of months. We also work still with University of Canterbury for their sounding rockets. We sponsor student projects. We launched from the Waikaia Rocket Proving Grounds at the north of Southland. These sounding rockets are looking mainly at guidance, navigation and control, and that's where their focus is. So this one only is going to go up to about 400 meters, but we've had rockets going up to 10 kilometers, I think is the most. We've got plans for a variety of other things, but that's really Chris Hen, probably better to explain that than me. We do get involved quite a bit with outreach. We feel it's important. We're a council-controlled organisation, so we feel there is duty to look after our ratepayers. So we have schools, and we've had astronauts and engineers and head of departments and head of missions speaking French here in a French class to reach out, and we've had some success. We managed to double the number of kids completing year 13 physics in Invercargill over a 5-year period where the rest of the country was going down. And I think one of my prouder moments would have been 5 girls, well, old girls from Southland Girls High graduated from engineering school at Canterbury one year. That was, it won't be all due to us, but certainly it helped. On the horizon, we'll be supporting the Capstone mission through one of our customers when it launches in the next few weeks. We'll be involved with solar weather follow-on mission at the L1 point Sun-Earth system. And we're working with partners to be involved with Lunar Gateway, which of course is at the end of the decade, and that's going to be more fun than we can imagine, I am sure, and we're looking very much towards that. So anyway, that's a short answer about what we do at Awarua, why Awarua is important, and how we can help any mission that might be going to space. There is another slide I realise I omitted to show, which basically says that ground segment is the bit that everyone ignores in the space community until they go to launch and then suddenly realise that the most important thing in the world is having a ground station. If you are going to space, get working on it 2 years in advance and talk to us early. Otherwise, you might well find it's harder than you think. And obviously more information at our website. So that's the end of my question. I see there's a couple, perhaps I could answer a question now, Jessica, or carry on.
So just we'll throw to those questions momentarily, Robin. We've had a few come through. We've had some come through in the chat, but again, like to invite all of our participants to share comments and questions with our speakers. We can throw to them for greater discussion. So there are two that are aimed. I think there's one that's asked of you, Robin, one that's asked of you, Duncan, and one that I think is likely relevant to both. So I'll start with the question that's aimed at Duncan, related to using AIS and targets that are cooperating by either putting in correct information or even turning it on. How does Starboard deal with non-cooperative targets?
Yes, indeed, it's a great question. Non-cooperative targets we call dark vessels. They're dark in that, indeed, they're not transmitting on AIS. How can we find them? We can find them from their navigational radar emissions, so I described that. We can find them if they are detectable in synthetic aperture radar, but that, even with the RadarSat-2 satellite we've been using, it is a big footprint, 225,000 square kilometers, but the ocean is a lot bigger. So that could be problematic, and finding them if, say, they're in an area where there's a lot of land can be islands or just sandy atolls sticking out of the ocean. That can also be difficult. So you've got to decide whether it's a vessel there or whether it's something else. That's synthetic aperture radar. What else can we do? I mean, they are supposed to have an automatic identification system going if they're over 300 tons or if they're any type of passenger vessel. If a vessel is fishing, and a large part of our focus for some time has been illegal fishing, if they're fishing within the exclusive economic zone of any nation, they're supposed to have a VMS system going, a vessel monitoring system. And those data are typically only available to that particular nation. But we are running a project just at the moment with a Pacific Island nation in which we do have access to the VMS data. So what feeds have we got? We've got AIS and VMS, which are actually announcing the position of the vessel. We've got RF satellites, which we might get one collection per day, and we map out over this nation's exclusive economic zone where the emitters are. And also we are running synthetic aperture radar collections. Is that good enough? Are we getting all of the vessels? Almost certainly no. On the other hand, it is very much a discouragement to fishing vessels which are trying to fish illegally, say fish within a nation's exclusive economic zone without paying the necessary license fee. So it's kind of like realizing that the police do indeed have speed radars and can detect you, and so you slow down. So it's an encouragement to them to behave, as it were. Another thing which I would note is, you may have noticed there's just been an election in Australia. The very next day, the new Prime Minister, Anthony Albanese, flew up to Tokyo for a quad meeting. That's Japan, India, the United States, and Australia. And one of the pre-meeting announcements has been about the need for exactly the sort of system which Starboard delivers. That is across the Pacific. There's a new project called Pacific Partnership. And the idea is that indeed we will acquire more and more data in which we can look for illegal fishing across the Pacific, because a lot of the nations there rely upon that not only for food, but also for their income. On top of that, of course, there are such things as trying to pick up vessels which may be drug running, trying to pick up things like vessels which haven't been back to port for 18 months and the implications of that in terms of human slavery and human rights and so on. There's all sorts of different ways in which we would like to know more about what's happening on our oceans, and Starboard is a contribution to that.
Thanks, Duncan. One of our attendees asked specifically of Robin, are there any antenna manufacturers in New Zealand?
Yes, there are. When you talk about antennas, you've got to be a little bit careful about, are you talking about TV antennas or all the way through to dish antennas? So, yeah, there's two of the UHF antenna manufacturers. We make our own, and also we've got under construction right at the moment another 3.7 meter dish antenna. And that's well in construction. For the dish antennas, it's not just the reflector, but also the positioner. We've also developed software and hardware for, moving a 3.7 meter antenna, which, if you think about it, it's got a lot of sail area, accurately to better than 0.1 of a degree and up to 100 km/h wind. So we've got that, and also the feed horn, what launches the radio waves into the reflector. That's actually quite a complicated and they're quite tricky, to be honest. So we work on that as well. So yes, there's no dish. There used to be one in Nelson. He's closed down. There's for Sky TV. It depends on the performance, but yeah, we do our own now. Well,
on the topic of people in your supply chain maybe being harder to reach or changing over time. There's a question that's been asked, I think specifically aimed at you, Robin, but I suspect it would be relevant to both, about the advantages of being in places in New Zealand outside of the major metropolitan centers. Have you encountered any, how has this been for your organizations in terms of getting a pipeline of suitably skilled staff for the projects that you work on?
Yeah, so the area we work in is something that's actually hasn't been taught really at universities for some time now. I mean, one way of looking at what the technology we use, it's a sort of 1970s technology, but using 2021 and 22 implements and components and solutions. You know, when you look at radio engineering, the universities, you know, they've long lost interest in 5G. They've moved to 6G and using more conventional platforms is something they don't really like to, you know, that's not very interesting for them. It's so the science is that we do is pretty straightforward. The engineering is actually quite difficult. So one of the great things I think about Invercargill is that we've got 3 national parks on our back doorstep and a great ski season. And so we have to sell an entire package of actually a lifestyle. And frankly, Invercargill, you know, we're at the end of the world, but it's only an hour and a half to Wellington, an hour to Christchurch, or 2 hours to Auckland in a plane, and the rest of the world. So yeah, we offer good benefits for living here, and I guess it also helps smooth out, so the staff who do want to work for us are actually committed, and they know they can get a lot of experience in a big hurry, and so we're pretty attractive for that.
From if I could, a quick answer, it's totally different, I guess, for Xera, in that we're not located in any one particular place. Our headquarters is in Alexandria in central Otago, and that's a very attractive place to live. I lived down there for 6 months or so. Nowadays I live in Nelson. We have about 25 employees that were spread throughout New Zealand. In fact, we did have a staff member living in Brisbane and recently left to take another opportunity there. We meet by Zoom. We work largely individually, but obviously we get together with some frequency. It's just a matter of click, click, let's get together. And so from the perspective of Xera, it really makes very little difference where you are. Obviously meeting people face to face and getting round a coffee table or a beer in the evening is something which is important. And we do have team days every so often, typically once every 4 months, where we gather in one place. But it's very much a distributed network of people working together on an hour-by-hour basis. And I guess as time goes by, especially since we're getting a huge amount of international interest, we will be spreading further. It may well be a matter of having people working out of different cities or different locations around the world, because that's where our major clients or indeed partners may be.
Thank you. There's been a question come across specifically to Robin. Robin, can you elaborate more on the role, on your organization's role in the gateway, the Lunar Gateway?
Yes, it's probably premature to talk too much about Lunar Gateway. I mean, Lunar Gateway is still on the go, and so we've got some colleagues in other parts of the world where we would be hosting a, let's just say we would be hosting a 13-meter antenna at Awarua, providing communications to Lunar Gateway.
All right. And can you comment on what role Space Hops might have after the launch of Capstone?
It's the Capstone is going to be supported mainly by one of our customers with who have antennas here at Awarua. So we'll be ensuring that the antennas are all working. My understanding is that it's only for the launch phase, and then we'll carry on to there'll be another deep space network, I'm sure, that will be communicating with Capstone, but yeah, it's probably Pete Beck's the right person to talk to about Capstone.
Thank you. We've just had a question come through. Could you, it's not clear to whom this is specifically addressed, so it may be relevant to both. Could you describe how you differentiate supplying data, even though it's through a visual platform, compared to supplying insight associating with data that you're gathering? That's actually probably more aimed at Duncan.
Yes, I think it is. Yeah, we don't supply data. I take the point, supplying insight. It's supplying analysis. So there's automated analysis, such as saying, for this particular track taken from AIS, what is this vessel doing? Where has it come from? Where is it going? Where has it been over the last 18 months or 24 months? We have access to many billions of AIS positions. So there's that automated analysis. So it isn't so much supplying the data to the client or the customer. It's a matter of supplying information and knowledge. So in terms of what we call the DICU hierarchy, that is data, information, knowledge, understanding, wisdom, what we're trying to do is, it's us who gets the data. It's too much for most of our clients. There's just too much. It's like trying to drink from a fire hose. There's too much. So we distill that into information, knowledge, and then we gain understanding from that. And the understanding which they derive from that, we hope gives them the wisdom. Such things as, for customs, we've got the resources in order to intercept and search 3 boats out of 20 we know are heading our way. Which 3 do we choose? That's the sort of thing which we try to do. Or for a Pacific Island nation, who is actually fishing out there? A lot of them, have, even if they've got patrol boats, patrol boats can only cover a tiny fraction of the ocean, and they're very expensive. So actually being able to tell them, hey, there's actually 3 fishing vessels 500 kilometers to the east of such and such, their town. That's a really useful thing for them to know. There really is virtually no other way to do that in an economic way, and it's becoming more and more economic because there's more and more satellite companies getting into this field, that is collecting specific sorts of data from orbit and then supplying it to companies like us who make sense of the whole thing.
Thanks. On the subject of insights and deriving insights, can you comment on how labor intensive or effort intensive the last campaign was in the search for dark vessels?
I would, yeah, that last campaign, Operation 18C, we had 3 people at the Indo-Pacific Expo, so doing live demonstrations there, which somebody's already commented very kindly about. In fact, we won, Matt Brown, one of our sales force, won the prize for the best pitch, 3-minute pitch, and Starboard won the prize for that through his presentation. So there's 3 people actually there. At the same time, there's another 3 or 4 of us who are actually looking at identifying satellite. I identify the satellite passes for which we want to acquire data. When is there going to be a suitable satellite there? And I think that our the companies we work for would regard us as being one of their more sophisticated customers, because we tell them specifically, this satellite's coming over, and at this set of 10 seconds, please collect, please orient your sensor in this direction and collect the data. So I do that side of things. We've got other people who do the analysis of the SAR imagery, but we're backed up by a tremendous software team, because I can't emphasize too highly how important it is to have really good people who know exactly what they're doing. That's one of the reasons why we're a distributed company. Rather than getting, as it were, forcing people to live in a certain place if they want to work for us, we rather take the view that we want the best people, and wherever they live, that's fine, we'll make it work. And that's what we do. But number of people for that particular operation, I would imagine it was probably the equivalent of about 7 full-time staff out of our 25. Over the we collected data for about a week before the expo, and then over the 3 days of the actual expo, we were showing things coming up live. Somebody asked me, how quick do we get the data from AIS? It's within 10 minutes. In Starboard, there's a icon comes up at the bottom right corner every few minutes, which says, bring in new data, question mark, just click it, yes, in comes the new set of data, which may be hundreds, thousands of positions within your screen, showing where the vessels have moved over the last 10 minutes.
Great. I think we've come to the end of the questions that we had. So thank you both, Duncan and Robin, for sharing your insights with us today, and appreciate the time that our audience has taken to attend and ask questions. It's really nice to host you and hear more about the part of the space system that people often overlook. So we hope that you'll all join us next month in June for our webinar number 6, which will focus on space situational awareness. If you've got comments or questions or feedback for the speakers or for us on this webinar series, please don't hesitate to reach out and connect. Our contact information is below. Emails are here. You can find us all on LinkedIn. Thanks again for your time, and see you next time.
Yeah, thank you, Jessica.
Thank you, everyone. Thank you. Thanks, Robin.